Coil versus air mountain bike shocks. What's the difference? Now, most people know that coil shocks are linear and air shocks are progressive, but most people don't know why. Now, I love physics to the point where I double majored in it in college, and so I'm going to break down why in this video. Starting with coil shocks because they're the most simple and they're governed by a thing called Hooke's law, which is F equals kx. And what that's saying is that F, the amount of force the spring is giving on an object at the end, is equal to k, the spring constant, times x, which is the distance the spring has moved, either compressed or pulled out from its equilibrium point. And so for mountain bikes, that just means that the more you move through the bike's travel, if it's using a coil shock, the more force you're going to have to apply to the shock to continue to move it. And that can be represented on this graph with force on the y-axis and distance moved from the equilibrium point as the spring is compressed on the x-axis, and you can see a very nice linear line. And that results in a very smooth, predictable feeling shock and pairs well with bikes that have a somewhat progressive suspension layout. Now, air springs are a whole lot more complicated, and if you're interested in seeing how I got all of these equations over here, I actually made a full-length YouTube video on my YouTube channel, so check that out. But I'll just summarize here. Basically, an air spring is going to be governed by a thing called Boyle's law, which is P1V1 equals P2V2, and what that's saying is that the initial pressure times the initial volume of the air chamber has to equal some pressure times volume at another instantaneous point. So at any point through the travel, the pressure at that point times the volume of the air chamber at that point must equal the initial pressure times the initial volume. And then through a bunch of deriving and assuming a single acting pneumatic air spring such as this diagram here, you get a final equation where you have the force at any point is equal to the initial pressure times the initial volume divided by the initial height of that air chamber times the distance it has been compressed. And if you graph that, you end up with this lovely progressive graph over here. So for a mountain bike, this simply means as that shock moves through its travel, it gets progressively harder to compress, which means that it resists bottom outs really well, and it can be paired with a bike that has a more linear suspension design. And it can also be tuned to pair with a bike that has a progressive suspension design. There's a lot more tunability in an air shock than a coil shock. So there we go. There's the differences between a coil shock and an air shock from a physics standpoint. Let me know if I should do more of these videos because I love physics and I love mountain biking, and so I enjoy making these videos. But I only want to make them if you guys enjoy it. So let me know if you learned something, if you want to see more videos just like this about mountain biking